When engineers from other car companies first saw a disassembled Tesla-plaid motor, the room fell silent. Not in admiration, in bewilderment. Because lying before them was something they themselves had been thinking about for years, yet had never managed to realize. And Tesla hadn't merely realized it, they were already putting it on the production line. And the most unsettling part, the company opened the patent to everyone. Study it. Copy it. If you can. This isn't a story about a single motor. It's a story about how one company rewrote the rules of the game once again at the very moment when everyone had decided the rules were already settled. To understand the scale of what's happened, we need to go back. In the early 2000s, the electric car was synonymous with compromise. Small, slow, with a pitiful range. Serious car manufacturers looked at this niche with arrogant indifference. Electric drive was for golf carts and urban delivery vehicles, certainly not for proper cars. It was precisely at this moment that Tesla was founded. Two engineers with an ambitious idea and virtually zero credibility within the industry. When Elon Musk joined the company and put his money into it, he brought not just capital. He brought a fundamentally different way of framing the question. Not, how do we make an electric car acceptable, but how do we make an electric car the best car in the world? The first Roadster proved that an electric motor could deliver genuine, physically tangible power. The Model S transformed the electric car into an object of desire for those who had previously looked only at BMW and Mercedes. Each subsequent model of the Model X, Model 3, Model Y broadened the audience and piled ever greater pressure on the competition. They responded by launching their own electric ranges, investing billions, hiring engineers, and assuring investors that they were on the verge of catching the leader. But while they were catching up to yesterday's Tesla, the company was preparing the next one. At the heart of the new development is a carbon-wrapped rotor. It sounds like something from a technical manual, but behind it lies a revolution in our understanding of what an electric motor is capable of. In most modern electric motors, the rotor E, the rotating element that converts electrical energy into mechanical motion, is made from copper and steel alloys. These materials have done their job for decades. But they have a hard physical limit. As revs increase, centrifugal force begins to deform the rotor's structure. Excess heat builds up, precision drops, and efficiency falls off at precisely the moment it's needed most, under maximum load. Tesla solved this problem radically. The rotor is wrapped in carbon fiber, the very same material used in Formula One cars, aviation, and space technology. Carbon is significantly lighter than steel, stiffer, and incomparably better at handling tensile loads at high speeds. The wrapping creates an external compressive pressure, a so-called pre-stress, that keeps the rotor's structure stable even at extreme revs. The result? Tesla's rotor is capable of spinning at speeds that most production electric motors have never reached. It is precisely these revs that directly shape the power and performance the driver feels when pressing the accelerator. The Model S Plaid accelerates from 0 to 100 kilometers per hour in under 2 seconds. Until recently, such figures existed only in the world of hypercars with price tags of several $1 million. But speed is only part of the picture. A lighter rotor requires less energy to spin. Less energy means the car travels further on the same charge. Less heat means the cooling system operates in a more forgiving manner. Less wear means the battery lasts longer. All of these effects reinforce one another, creating a chain reaction of improvements throughout the entire system. There is another factor that gets less attention: thermal stability. In conventional motors, heat is the primary enemy. When metal heats up, it expands unevenly, creating microscopic imbalances that over time lead to wear and a loss of performance. Carbon wrapping behaves differently. It maintains even pressure on the rotor regardless of temperature, ensuring stability across all operating conditions. In other words, this is simultaneously the fastest, most efficient, and most durable motor Tesla has ever built. Now, to the most interesting part. Why does the open patent give competitors no real advantage whatsoever? Wrapping carbon around a metal rotor is a task that's trivial on paper and extraordinarily difficult in practice. Carbon fiber and metal, the copper and steel inside the rotor, have different coefficients of thermal expansion. Put simply, when the temperature changes, these materials expand and contract at different rates. If the wrapping is applied without exceptionally precise calculations, the carbon layer can delaminate, crack, or, far worse, cause a critical imbalance at maximum revs when the motor heats up during operation. To solve this problem, Tesla built from scratch a robotized system controlled by artificial intelligence, capable of applying the carbon layer with an accuracy of 1 micrometer. Not a millimeter. A micrometer, that is 1/1000th of a millimeter. The system simultaneously monitors fiber tension, ambient temperature, winding speed, and lay angle. After each rotor, there is a laser inspection with no tolerance for the slightest deviation. This is the essence of the open patent strategy. Tesla is essentially saying to the entire industry, we have moved so far ahead that we can show you the route map, and it still won't help you. Because a map is not a machine. A patent is not a production system trained on thousands of tests. And even if a competitor builds equivalent equipment, they still have to integrate all of it into a production line capable of turning out tens of thousands of units per month. The openness here is not generosity, it's a demonstration of the gap. However, an honest analysis requires speaking not only of successes. Carbon technology with micrometer precision is an expensive business. Each rotor demands machine time, costly materials, and individual inspection. For now, this motor remains the preserve of top-spec versions. Whether Tesla can bring it to mainstream models is an open question. The financial pressure is real as well. The price war with Chinese manufacturers, BYD, NIO, and others, is growing ever fiercer. These companies produce millions of vehicles at significantly lower cost and are aggressively entering international markets. In a price war, technological superiority does not always determine the winner. A significant risk is the overdependence on Elon Musk as a personality. His controversial statements, delayed promises, and social media scandals all affect the perception of the brand, particularly among older buyers, for whom trust in a company matters more than any technical specification. Charging infrastructure remains a psychological barrier for many. Tesla's supercharger network is a serious advantage, but as it opens up to other brands, that advantage becomes less exclusive. And finally, full self-driving. Tesla has been promising it for years. Progress is being made, but the gap between promises and reality persists, and this undermines confidence. As for the competition, the picture is mixed. Lucid Motors demonstrates impressive engineering solutions and record-breaking range, but sells vanishingly few cars and operates exclusively in the ultra-premium segment. Rivian is carving out its niche around electric SUVs and pickup trucks, but lags noticeably behind in pure motor technology. Ford has proved that Americans are willing to buy electric trucks, yet remains dependent on external component suppliers and has been forced to scale back production plans on several occasions. GM has invested colossal sums in electrification, but the Ultium platform has yet to produce a single technological breakthrough comparable to what Tesla has achieved. BYD is a different story altogether. The Chinese company has overtaken Tesla in total global electric vehicle sales, manufactures its own batteries and key components, giving it a significant price advantage, and is pushing aggressively into Europe, Latin America, and Southeast Asia. But in the United States, BYD faces tariff barriers and weak brand recognition. American buyers, particularly older ones, still tend to prefer familiar names. This is a temporary advantage for Tesla, but for now, it holds. No single competitor threatens Tesla on all fronts simultaneously. Some have the engineering but not the scale. Others have the scale but not the brand. Others still have the brand but neither. Tesla for now combines all three. And finally, the thing that gets the least attention, yet may prove the most important. When presenting the new motor, Musk mentioned that its characteristics, low weight, thermal stability, the ability to run at high revs for extended periods without losing efficiency, make it interesting well beyond the automotive industry. Electric aviation, industrial installations, energy infrastructure, anywhere a light, powerful, and reliable motor is needed. Tesla has made no official announcements about licensing the technology for aviation, but the logic of its development is clear. A company that already manufactures batteries for national energy grids and home solar generation systems is gradually becoming not merely a car manufacturer, but a platform for the energy transformation of an entire era. The history of technology, however, has shown more than once that the technical leader does not always become the commercial winner. Betamax was better than VHS and lost. BlackBerry had the better keyboard and disappeared. Nokia seemed unshakable until it became history. The electric vehicle market is still taking shape. Government policy is shifting. Battery prices are falling. Geopolitics is reshaping supply chains. In such conditions, even the most impressive technological breakthrough does not guarantee victory. But one thing can be said with certainty. What is happening in the electric vehicle industry right now, the technological race, the price wars, the battle for infrastructure, will define the shape of transport for decades to come. And the next few years will be decisive. What do you think? Has Tesla genuinely changed the rules of the game once again, or are competitors preparing a response we don't yet know about? Let us know in the comments, especially if you own an electric vehicle or are in the process of choosing one. If this video has given you a fresh perspective on what's happening, give it a like. It'll help the content reach more viewers. And subscribe to the channel so you don't miss the next in-depth breakdown, not just about Tesla, but about everything that is transforming energy and transport across the world.